my name is Jingyi. I'm a PhD student from Professor Zhang's group at CUHK. In this video, we will look into the submission subcommand in CHEMSMART. CHEMSMART features two main execution modes. The first is CHEMSMART run, which executes jobs locally on your machine. The second is CHEMSMART sub, which submits jobs directly to an HPC queuing system. In this tutorial, we will focus entirely on sub, since heavy quantum chemistry packages like Gaussian are typically offloaded to a high-performance computing cluster. The key concept to keep in mind is separation of concerns. Sub controls where and how your job runs, whereas the subsequent chemistry subcommands control what type of calculations is actually performed. The submission layer handles cluster-level configurations like target server, memory allocation, and core counts. Once those logistics are handled, the subsequent layers dictate whether we are spinning up a Gaussian job, an ORCA calculation, a thermochemistry analysis, or a visualization task. Here are the server and resource options available to you. Please note that the -s option takes the server configuration name without its .yaml file extension. If you need to scale up your resources, you can use the -n, -g, and -m flags to easily override the default server limits for CPU, GPU, and memory. Next, let's look at execution control. By default, CHEMSMART runs jobs inside a dedicated Scratch directory and automatically copies the output files back to your working directory upon completion. To set up your Scratch environment, simply create a symbolic link from the Scratch directory in your home folder to your preferred storage path. You can easily modify this behavior using the Scratch or no Scratch flags. By default, CHEMSMART retains output files in your Scratch directory. Using the delete Scratch flag if you want CHEMSMART to automatically clean up and delete the Scratch space once a job completes successfully. To summarize, in this video, we covered the fundamental differences between running jobs locally and submitting them to an HPC queue. We explored how to target specific servers, customize resource allocations like memory and CPU cores, and manage runtime behavior using Scratch directories. With these submission tools mastered, you are now ready to efficiently scale up your computational workflows. Thank you for watching, and happy computing!